Hello everyone, I am Romulo Stringhini from the Federal University of Santa Maria, and I will present you the paper entitled Noise Reduction with Detail Preservation in Low-Dose Dental CT Images by Morphological Operators and BM3D. For this presentation, I organize as it follows. First, I will give you a brief introduction about the problem discussed in this work, some state-of-the-art techniques. Then I will show you the materials and images used in this study, the proposed method, the experimental results and validation, some discussion, and finally I will summarize and conclude this presentation. So, computed tomography is an extremely important tool that examines internal structures of a human body, providing an accurate medical diagnosis. And the dose of radiation is directly associated with the quality of the image acquired in this type of exam. That is, a high radiation dose will provide you a high image quality. On the other hand, a low radiation dose will provide you a low image quality. However, exposing patients to high doses of radiation is detrimental to their health. Because of that, the medical community has been following the ALARA principle, which aims to minimize the radiation dose at a as low as reasonably possible level, while maintaining an acceptable diagnostic accuracy. So low-dose CT exams will provide you a low image quality, which will be degraded by undesirable artifacts, which are known as noise. And to remove this noise and improve the quality of such images, several filters have been proposed in the literature with this purpose. And few examples are the bilateral filter, the block matching 3D, the bitonic filter, the morphological open-close sequence filter, the guided filter, the progressive switching median filter, switching median morphological filter, the non-local means, and many others filters have been proposed in the literature. So all the images used in this study were taken from an anonymized database from the University Hospital of Santa Maria and consists in a total of 991 images. And all of them are low-dose computed tomography dental images. As you can see, there are noise in all structure, in all the slice here. So in the gray structure, as we call the foreground region, you can see the noise, and in the background region, you can also see the noise in these areas here. So because of that, we propose a method in order to reduce the noise and preserve details, important details and structures, which is based on mathematical morphology operators along with a 3D filtering technique. And our proposed noise reduction method is divided into two main stages, named as image segmentation and noise filtering. The first stage, the image segmentation stage, we divide the input image into two other images containing only the foreground region and one image containing only the background region. So we start with a noisy low dose image as input. We convert to its grayscale level. We apply a morphological opening by reconstruction to improve the performance of the Otsu threshold method. In this step, we find the pixels that has high contrast when compared to the background region pixels in order to obtain the noisy foreground region. For that, we apply an element-wise multiplication between this image and the grayscale level image, which we will denote as F5. And in order to obtain the background region, the noisy background region, we simply subtract this image from the grayscale level image and then we're gonna obtain the background region. So here's the grayscale level image, the original image. Here's the image resulting from the morphological opening by reconstruction. Here's the image where the high contrast pixels were found by applying the Otsu threshold method. Here's the noisy foreground region, and here is the noisy background region. As you can see, we're gonna work with these two images separately. So F5 and F6 will be the input images of our second stage, the noisy foreground and the noisy background. So for the noisy foreground region, to remove the noise in the foreground region, we're gonna apply a morphological opening operator with a diamond-shaped structuring element of size 2. Then we're gonna correct the contrast of this image by applying the Clary operator. Afterwards, we're gonna apply a reconstruction by dilation in order to restore the degraded components affected by the morphological opening operator. And to completely denoise the foreground region, we applied a BM3D filtering technique, which we're gonna obtain F10, which is our noise-free foreground region. And for the background region, in order to remove the noise present in this region, we just applied a morphological opening operator with the same structuring element as used in this step. And in order to obtain the final output image of our proposed method, we just add these two images and we're gonna obtain the final output image. So here is the noisy foreground region. Here's the image resulted from the opening operator. Here's the image resulted from the Clary contrast equalization algorithm. Here is the image resulting from the morphological reconstruction by dilation. And here is our noise-free foreground region, the processed foreground region. And here is the original image to the left, and to the right is our final output image of our proposed method. As you can see in the background region, the noise was completely removed, and in the foreground region, the noise was also completely removed, and important details and structures was well preserved. Here is another example, the original image to the left, and to the right our image resulting from our proposed method. As you can see, important details and structures were well preserved and the noise was well reduced, was well removed. So we conduct extensive simulations on our database, on our 991 low dose images. We compared with 16 state-of-the-art noise reductions, noise reduction filters, and we used the peak signal noise to ratio, the structural similarity, the mean squared error, and the edge preservation index as quantitative quality metrics. And as you can see in table 1, our method outperformed all the filters evaluated in both quantitative and visual terms, obtaining the best average results for each metric. So, as you can see, here is the image obtained from our proposed method. Here's the image obtained after using the open-close sequence filter, and here's the image resulted from the adaptive weighted median filter technique. As you can see, the noise wasn't well removed, and the structures and details were badly degraded by these two filters. On the other hand, we managed we managed to obtain a good visual aspect by preserving details and structures and by removing the noise completely from the image. Here's another example. Original image, output image from our proposed method. The noise was completely removed from both regions, from both foreground and background regions. So to summarize and conclude this presentation, this study introduced a method based on mathematical morphology operators and BM3D filtering technique in order to reduce noise and preserve details in low-dose computed tomography dental images. Our proposed method was tested on 991 noisy images and compared with 16 different state-of-the-art filters. Our proposed method outperformed all the evaluated filters in both noise reduction and detail preservation terms. Also, we obtained superior average values in all quantitative quality metrics used. We would like to thank CAPES, the Coordination on Improvement of Higher Level Personnel, which financed in part this study. Here are some references used in our paper, in our study. And that's it. Thank you for your attention. And here is the contact if you are interested in further informations.